Hello students, let's continue with our food processing presentation. So in the previous presentation we talked about food processing. We talked about the different methods, the chemical methods, biological and physical methods. And I also mentioned that physical methods were like the most important processing methods. Today we're going to talk about non-thermal processing, which is sometimes called alternative processing. So today's objectives are a recap of thermal processing, explain the importance of non-thermal processing, discuss non-thermal technologies, and identify the types of foods most commonly used in non-thermal processing. So thermal processing recap. So if we think about a timeline in the 1860s, there were many discoveries about the role of microorganisms, and we have talked about them previously. We have microorganisms that are very good and that we use very widely in the production of fermented foods, like yeast, lactic acid bacteria, molds in cheese making, and we also use a lot of uh, microorganisms and fermentation processes for the production of pharmaceuticals and other products in what we call biotechnology. But we also know that there are some microorganisms that we call pathogens and also others that are spoilage microorganisms that we have to consider and we have to take care in order for them not to be in our food products. We have to inactivate them or inhibit their growth so we don't have any health issues or quality issues with our products. Then in 1874, the pressure cooker was invented, and this is very important because pressure cooker cooks food at a higher pressure, and because of higher pressure, higher temperature, and this will decrease the cooking time. And this is like what goes before the invention of retorts or retorts for sterilization processes in like the canning industry. And then in the 1900s, we discovered the relationship of time and temperature in thermal processing. And as I mentioned before, time and temperature are so important for thermal processing. Like if we use pasteurization, we mention 72 degrees Celsius for 15 seconds. If we use what we call HTST pasteurization, we go a little bit higher. If we use UHT, so it's ultra high temperature pasteurization, so around 95 degrees Celsius for like 1 second. And then depending on the type of package, we'll have different combinations. We also can use a process that is called hot fill process that is used for the Gatorade beverage, and also for jams and jellies, which requires the temperature to be 85 degrees Celsius. Then we have sterilization processes at 121 degrees Celsius, and depending on the type of product, it can vary. The times can vary. And then in the 1920s, the safety standards for Clostridium botulinum were established, and this is a pathogen, as we have discussed before, that is very critical in thermal processing, mainly in food that has high pH, and some examples will be like tuna, meat, beans, and so this applies to all canning and products that are in pouches. So now there's also a trend for using different types of materials for canning and this type of foods because of consumer needs and requirements for new packaging, more convenient, and so. So if we think about this thermal processing not keeping our food safe, and the answer is that yeah, heat treatments are very effective in eliminating or reducing spoilage organisms and pathogens. But in the 1980s, there was a movement, so how to get more out of food. So we know that thermal processing is effective. So it reduces, sometimes we call this type of reduction the D reduction. Sometimes we say that sterilization will reduce 12 Ds, pasteurization 5 Ds, and these, of course, thermal treatments will reduce the microorganisms. So why do we need other alternatives? So the thing is that thermal treatment can reduce attributes of food like flavor, color, and texture, because depending on the type of food, we require very severe treatments because of that nature of the food I mentioned before, the high pH. We have to make sure that we don't have any probability of CBOT, Clostridium botulinum, being in the food, because it's a very dangerous bacteria. But if we heat something for a very long time, we of course will affect the flavor, color, and texture. And there's a lot of efforts for optimization of thermal processes, and with new technologies, there's a lot of work done, and we have thermal treated foods that are very good quality, flavor, color, etc. But then in the 1980s, there was this movement that, well, we can have other types of technology, and we can have what we call foods to be fresher, to have a freshness, to keep the freshness in food. And then, as we see here in the picture, most juices are heat pasteurized. And this, of course, can lead to the loss of vitamins in this type of juice, of other compounds, antioxidants, with phytochemicals and so. So what are the benefits of non-thermal? So non-thermal will keep products fresher, and also there's the advantage of some energy savings. As I mentioned before, the food industry uses a lot of water, energy, and produce a lot of waste, and these are the challenges of the food industry. So if we have a technology that uses energy, reduces energy costs, that would be great. The thing with non-thermal is that they are a group of technologies, and they are relatively new, and if we don't have like what we call economies of scale, so if they sell very few units, the prices are going to be very high, and there's still a lot of work to be done in regarding non-thermal processes, and the benefits they can have. So is all non-thermal acceptable? So non-thermal is a group of technologies, and they are new technologies. So they need what we call validation by federal agencies such as FDA and USDA. And also they need to be approved by consumers. And what do we mean by validation? So validation is research has to be conducted to determine the effectiveness of non-thermal is the same as thermal. So as I mentioned before, when we use thermal, we are sure that the process is inactivating the microorganisms. We are achieving what we want, the reduction of microorganisms, the inactivation of microorganisms. When we use thermal processes, we can have food stored at room temperature, depending on the type of process. But we don't know that for all non-thermal processes. There's a lot of research that needs to be done. We have to be sure that the technology that we are applying is inactivating microorganisms. But not only that, that when we buy the product and we store it in our house, that we also are safe, and that we have the shelf life we need, and that nothing bad is going to happen in our food. So that's what we call the validation. So we have to make sure that the products that we are selling with that have been processed with non-thermal technologies are safe for the consumers, and that's a lot of work that has to be done and has not been done yet. So one of the terms that I want to introduce is called minimally processed. So people want things that are natural, not a lot of processing. So this term is used to convey new technologies for the consumers, and minimally processed implies retention of freshness. So when we talk about minimally processed, let's take an example of a salad, like ready-to-eat salad, right? So if we want a ready-to-eat, let's take a very easy example, and we have lettuce or spinach. So we have lettuce or spinach from the farm, harvest them, we take them to the factory, and then we need to have a very light processing. So we need to wash or disinfect the lettuce or the spinach, and we can use different types of technology like chlorine or a chemical like chlorine, or we can use ozone or other types of disinfection technologies. Then we disinfect them, and then we package them, right? So this is a very what we call minimally processed. We package them, and then the salad bags are stored in the fridge, and the shelf life is short. Like let's say 2 or 3 weeks, most 1 month, depending on the type of salad. And so this is what we call a minimally processed food. So no heat is applied. Just refrigeration is required to inhibit the growth of microorganisms. And there's a lot of challenges because these type of foods have not been heated, and the safety standards have to be very high because there's a lot like contact between the workers and the food. There has to be a lot of like safety implementation plans that we talked about them in the previous week, and this is very important. Another example would be like, say, the baby carrots. So that's another example. The carrots are clean, disinfected. They are cut into these shapes. So it's a normal carrot that has been cut into these baby carrot shapes, packaged and in the fridge. Other examples will be like things that like have been chopped or sliced, and there's a cleaning, washing, disinfection process, packaging, and then in the fridge, and then we can buy these types. So these are examples of minimally processed foods, or some type of meats that are in the fridge. They maybe have been marinated or so there's not a lot of process involved. No heat applied, and so what are the types of non-thermal processes? Processing. There are several examples. We're going to talk about some of them. First one is high pressure processing. The second one is ozone. A third, UV light or ultraviolet light, pulsed electric fields and pulsed light, and irradiation. Sometimes we say non-thermal processes, but in some of these technologies there's an increase in temperature, not a very high increase depending on the type of technology, but it's also important to think and to consider that in some of these technologies we can have increase in temperature. There's other processes that we call them alternative processes, and that there's an increase in temperature, but they are also alternative technologies like microwaves, optic heating, radio frequency, and ultrasound. So there's a lot more technologies, but these are just the most important ones. So high pressure processing, it's called HPP, and also it's referred to as high hydrostatic pressure processing. So foods are placed in sealed pouches, and pressure is conducted through water in a sealed vessel, and HPP preserves the freshness of the product. There's less flavor change compared to thermal process, less structural damage or denaturation of proteins, and fewer or no additives are needed. Here's a video of hyperbaric high pressure processing impact. So in this video, you're going to see how the high pressure processing plant works. And when it says impact, is because the food is packaged first and then it is processed. And so I recommend that you watch the video. And this technology, so one of the main products or the first products that have used this technology are avocados. So guacamole, as you may know, guacamole is made from avocados, and heat is not something that we want to apply to guacamole, so it will not taste good, it will be very bad. And the main problem with avocados is browning, and that browning is because of an enzyme that is present in avocados, and when it is exposed to oxygen, it causes browning. So the main target in high pressure processing for avocados is to inactivate this enzyme. So this enzyme, when it is exposed to oxygen, it acts very fast. And one of the main first products processed with high pressure was guacamole. And there's a lot of avocado products, not just guacamole, but like smoothies with avocado and so. A lot of other examples are juices, pasteurized with high pressure, and some types of seafood. And so there's, as I explained before, normally high pressure will achieve a like equivalent of a pasteurization, and in some cases a post refrigeration storage is needed. And in some cases, depending on the type of technology and packaging, we can have a shelf stable products. Like some companies, say in Latin America, have juices, orange juices processed with high pressure, and they are shelf stable. So how HPP works? So the pressure causes inactivation of microorganisms and enzymes. As I mentioned before, the enzyme responsible for brownie is called polyphenol oxidase. The equipment is expensive, but energy costs are lower. And normally, as I mentioned before, we can produce refrigerated products. And the amount of, this is a graph of the pressure. So in the Everest, we have 0.03 megapascals, at sea level 0.1 megapascal, and then when we use pressure treated foods, we use between 100 and 1000 megapascals. Normally doses are most commonly used doses are around like 500 and 600 megapascals, and this will depend on the type of food and the type of microorganism or enzyme that we want to inactivate. Then we will go to UV light, and this is another technology. Its best use is for surface disinfection or clear liquids. And the reason that we use it for surface or clear liquids, it's because it has a very short penetration depth. So it cannot penetrate or have an effect in like very thick liquids or opaque liquids. So we need either clear liquids, like let's say a clarified apple juice, or we need it's used for disinfecting surfaces like fruit surfaces, like papaya surfaces, where we can see some type of mold growth, or to prevent mold growth. So disinfecting surfaces, or very clear liquids, and it can be an alternative to pasteurization, but it is mostly used for disinfecting surfaces. So the other technology that we have is post-electric field, also known as PEF, and post-light. So post-electric field causes the destruction of the membranes, and this leads to microorganisms' death. And well, this is important to mention because each of these technologies has a different or sometimes share like inactivation of microorganisms mechanisms. So in this case, we know microorganisms have cell membranes, and this type of technology will destruct these membranes. In other technologies, we can see denaturation of proteins, but most of the times it's something that has to do with the membrane. And as we know, membranes will, like say cell membranes will control the inlet and outlet of ions and other types of compounds. So if we destroy the membrane, then this will lead to death of microorganisms. In the case of pulsed light, it's similar to irradiation, and it's very good for disinfecting surfaces. And as pulsating provides a burst of energy that can disrupt the cell membranes, and it will do this better than continuous energy or light. So one of the most commercially successful technologies of pulse electric field is a pre-treatment of French fries, potato fries, or sweet potato fries. So after they are cut in the right shape, they go through this treatment. And then what this treatment does is so the purpose of this treatment is not really the destruction of microorganisms, but it's something in the texture that changes, and this helps the next process, which is frying, to be better. So the frying process becomes more efficient. The use of oil decreases because of this change in texture, because of the PEF pre-treatment, and this is one of the best examples of how technologies or these new technologies are used. I also recommend that you watch the videos that are in the overview page of week 4 for food processing. As I mentioned before, they are going to be also in the exam. Another example is irradiation, and irradiation are gamma rays of cobalt-60 or cesium-137, and these electron beams are high energy, up to 10 mega electrovolts, and these are similar to X-rays. So let's say that X-rays will have energy up to 5 mega electrovolts, and electron beams will have double this energy. So its main function is to kill pathogens, insects, parasites, inhibits spoilage microorganisms, and is very widely used in, for example, disinfection of spices, of meat, and it has reduced a lot of pathogens and help reduce a lot of deaths and health issues with this type of products. Foods approved for irradiation. There's a variety of foods: the beef and pork, crustaceans, fresh fruits and vegetables, lettuce and spinach, poultry, seeds for sprouting, like alfalfa sprouts, shell eggs, shellfish, and spices and seasonings. And I also recommend that you watch the videos related to how irradiation can help with food safety in specific countries, and also how irradiation works. So irradiation is a very interesting technology, but it has had a lot of negative press and acceptance from consumers. So if foods have been irradiated, they should have this symbol, and this symbol is called the Radura symbol. So if you see this symbol, it means that this food has been irradiated, but it's normally used for wholesale. And the purpose of this is that food that has already been irradiated will not be irradiated again. If foods are used and they so ingredients are added into foods and they have not been irradiated, there's no special labeling on retail packages. So if you use something as an ingredient, even when it has been irradiated, and you use it somewhere else, you don't have to label it. And there's no requirement for foods that are in retail. And then you can see this link about an overview of irradiation of food and packaging. And as I mentioned before, most of the foods that are processed as a wholesale and have been irradiated should have this symbol, but there's still some work that has to be done for, like here, spatial labeling is required for foods that are not yet in the retail market and may undergo further processing to ensure that the foods are not irradiated multiple times. So that's what we don't want, foods to be irradiated more than one time. So there's irrational opposers of irradiation. So really, radiation is a safe technology. It helps a lot in many countries, and you should watch the video about how irradiation helped in Cuba. But there's a lot of like safety and how it affects irradiation, but it's mainly because of the processing facilities that are required, and the safety, because we're using gamma rays, and also the part of like socioeconomic, it may contain statement from allergies. So the important thing is that irradiation cannot be used to cover poor sanitation practices, which would be very bad. But yeah, irradiation also needs a lot of has had a lot of like bad presence. So, but in reality, it helps a lot with the safety of foods, and has prevented a lot of like health issues. Here are some irradiation videos. Food irradiation, making fruit and vegetables last longer, and how those food irradiation work. So, as I mentioned before, sometimes the reality that we live in the US is different from the reality in other countries. So if you can have a technology that will make your fruits and vegetables last longer, or you can make sure that the meat you have is going to last longer, or kill pathogens, why not, right? But yeah, there's still some work that has to be done in terms of consumers' acceptance and so on. So the final questions are: what foods are best fit for non-thermal processing in terms of like say HPP, PEF, irradiation, and the others that we mentioned, UV, ozone? And what non-thermal processes are best fit for disinfecting surfaces? So with this, we finish our food processing and non-thermal processing sections. If you have any questions, please feel free to reach out. And next week, we are going to talk about food law, food regulations. So see you in the next presentation.